this problem will give me an opportunity to remind us of some of the exponent rules that we discussed in class, or what I called the exponents rule. Okay, 10 cubed times 5 cubed. We're trying to compare this with the number 10 cubed. 2 cubed times 5 cubed and 10 cubed. Now, you could just use a calculator. It's not dishonest, but it's you can actually use a calculator and figure out which one is larger, but I'm going to try to remind us of some of the rules so we can compare this more easily. And what I'm going to remind us of here over here in red is I'm going to write down that x to the n, y to the n is equal to xy to the n. Because that rule right there says that if you are multiplying two things, two exponential expressions, and the exponents are the same, which they are, then this is equivalent to multiplying the bases and raising that to the same power that you had. So 2 cubed, 5 cubed would be identical to 2 times 5, which is 10, cubed. So equals. This one is an equality. Okay, stage 2. 2 to the 5th times 2 cubed, how does that compare to 2 to the 8th? Again, calculator, completely valid and will give you the correct answer, but let's remind ourselves of what x to the n multiplied by x to the m is. So remember that from lecture, x to the n means n many copies of x, and x to the m is m many copies of x. So altogether, we are multiplying together n plus m many copies of x. So the rule here is that when the bases are the same and you're multiplying two exponential expressions, you add the exponents. Here, the bases are the same. So if we do 2 to the 5th times 2 to the 3rd, we're going to get 2 to the power of what we get when we add the two exponents. 5 plus 3 is 8. So this one's equal too. Okay, the last one, I'm going to show a little bit of a technique in here. This one, since the bases are different and the exponents are different, we can't straight up use one of the rules, but I'm going to use a sneaky simplification here that actually uses both of the top rules. I'm going to use the fact that 3 to the 5th times 5 cubed is the same as 3 squared times 3 cubed times 5 cubed. To get from here to here, I used the second rule, the fact that 2 and 3 add up to become 5. Now this is the same as 3 squared times 15 cubed. And here I'm using the top rule, the fact that the exponents are both 3 and 3 means we have a 15 cubed. So this means that the 3 squared 15 cubed expression is identical to 3 to the 5th times 5 cubed. So on the right hand side we have 15 cubed. On the left hand side we have something that's equivalent to 9 times 15 cubed. So clearly the object on the left is larger. This ability to manipulate exponents like this is very useful on standardized tests like the SATs or GREs.